Hi, I'm Caitlin, one of the youth librarians at Skokie Public Library, and joining me today is...
Desi!
Today, I am excited to talk to you about something that is on my mind and pretty much all over all my stuff all the time. I'm talking about glitter.
Ooh, really, Mom?
Too controversial?
Very polarizing topic.
Who doesn't love sparkling?
I think it's less about the glitter and more about the litter. I think I have a solution that everyone can get behind, though. Crystals.
Oh, I love crystals.
Everybody does. From dazzling jewels to the minerals that flavor our food, even inside the pencils we write with. Crystals are everywhere.
Wait, pencils? What do pencils have to do with crystals?
I know, they don't seem like they have anything in common, right? Let's talk about this. You know how we're all made up of atoms?
Oh, you mean the basic building block on which all matter is made? 100%?
That's right, you matter.
Unless you multiply me by the speed of light squared, and then I'm energy!
Nerd.
Yes. In science, matter is described by the way it's made.
Atoms and molecules.
Exactly. If those atoms and molecules are arranged in a regular way, a pattern, then they're a crystal.
Or scientifically, a crystalline solid.
If they're just in there all randomly, they're what's called an amorphous solid.
I love the word amorphous.
I don't know. It's kind of all over the place.
I see what you did there.
But getting back to our regular pattern...
Ugh, Mom. Okay, to summarize, crystals are made up of a bunch of atoms and molecules that form a regular pattern. On the outside, this looks like a bunch of flat surfaces that meet in sharp corners. You can see this in snowflakes, salt, and sugar, and lots of different gemstones like diamonds, sapphires, and rubies.
Okay, I hear what you're saying, but that is not what a pencil looks like.
Touché. Okay, get ready because you're about to learn a whole lot of cool stuff about graphite.
Graphite?
The part of the pencil that writes is made out of graphite. Graphite is a crystalline form of the element carbon.
Not amorphous?
Nope, its molecules are neat and orderly. Graphite is really interesting.
I mean, who isn't enthralled by pencil tips?
Okay, Mom, you're a librarian. We know you love writing. But did you know that graphite is the only non-metal that can conduct electricity?
That's cool, I guess.
It's a super cool mineral. Natural graphite is really soft and feels kind of slippery, but it's also very heat resistant. Because of this, it's used in all kinds of really different ways, like batteries for electric cars, paint, and of course, everyone's favorite writing utensil, Old Reliable.
All right. This is not the graphite show. Let's talk about some other crystals.
Oh, you mean like one of the world's most popular and oldest forms of seasoning?
Cilantro?
Gross.
Just kidding. I know you're talking about salt. When salt meets water,
Like the ocean.
it dissolves into a solution. When the liquid evaporates, salt crystals appear.
The same is true of sugar. And that brings us to our first experiment, making rock candy.
For this experiment, you'll need some glass jars or cups, some popsicle sticks or skewers, food coloring if you like to get fancy, 6 cups of sugar, 2 cups of water, and a grown-up because you're going to have to boil that water. You're also going to need something to keep your stick from touching the sides and bottom of the glass. Haven and I tried a couple of ideas. I think either clothespins or wedging our skewer between rubber-banded popsicle sticks work the best.
The crystals need something to build on, so the first thing you'll do is wet your skewer and roll it around in some sugar to create a base layer. While that is drying, bring your water to a boil, then slowly add your sugar, stirring constantly so it dissolves.
6 cups of sugar for 2 cups of water may seem like a lot, and it is. You're actually creating a super saturated solution.
That's when you have a lot more of the stuff you're dissolving than you need.
Once all your sugar is dissolved and your solution feels a little syrupy, remove it from heat and let it sit for about 20 minutes. While it's cooling, make sure your jars are warmed up. You can just rinse them with hot tap water, then add your syrup. Now's the perfect time to add food coloring.
These crystals are going to take about a week to form, so put your jars somewhere where they won't be in the way for a while. Place your skewers and wait.
We were really excited about this experiment because A, crystals, and B, candy. And I'm going to go ahead and admit that this was not the most satisfying experiment. Though overall it was successful, only 3 of the 5 sticks we prepared gave us decent results, and it took a really long time, and I am not that patient.
That's an important lesson, though. Science is not always satisfying. That doesn't mean you didn't learn anything or it wasn't meaningful.
True. If we try this experiment again, we have some really good questions to test. Like, what made the green crystals grow so much more than the red or the blue?
We ran another experiment with much more satisfying results. Borax crystals.
For this experiment, you will need a large jar, some string, a pipe cleaner, a skewer, food coloring, 3/4 cups of borax, 3 cups of water, and once again, a grown-up because that water has to be boiled.
While your water is boiling, twist your pipe cleaner into any shape you want. Haven turned hers into a little cat face.
Combine the borax and the boiled water, then add food coloring. I recommend adding a lot. Finally, you're going to tie the string to your pipe cleaner, then dangle it from your pencil or your skewer. Just make sure it can hold a little weight.
Submerge it in the water and leave it overnight. My hypothesis is that the longer you leave it, the more crystals you'll have. If you test this, leave your results in the comments. Haven left hers in for about 24 hours.
Well, that's very beautiful. But you know what I always say.
This project could use more glitter.
Yes! And also, the best way to learn a new concept is through a catchy song. If you sing a catchy song,
You'll never get it wrong.
glittery, sparkly little crystals gleam on necks, fingers, and wristles.
Crystals?
It was the best I could do.
You sparkle 'cause your molecules play by some specific rules.
They have to form repeating patterns.
Or else they're just amorphous matter.
Thanks for adding a little dazzle to our day, junior crystallographers. We will see you next time.
Until then, may the quartz be with you.